summation notation, okay? Hopefully, guys, you'll find factorials very easy. If n is positive, if n is positive, positive integer, sorry. So if n is a positive integer, then n factorial, it looks like an exclamation point, and we do actually have it on your calculator, is defined as n times n minus 1 times n minus 2 times n minus 3 dot 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 until you get down to the final integer, which is the number 1. It's all multiplication. So you take the n times n minus, so for example, guys, 6 factorial is 6 times, anybody know where we go next, gang? What's 6 minus 1?
5.
6 minus 2?
2.
Blast off. Now, I know you can multiply those out by hand. I want to show you where the factorial button is. So right now we have to do it by hand. How about that? Thank you for asking. I put 726. Okay. All right. This should be, since this is a continuation of our last notes, this is example 3. Evaluate the factorial no calc. So what I'm saying is, guys, you can't just use the button. Letter A is 10 factorial over 2 factorial times 8 factorial. Letter B is n plus 1 factorial over n factorial. What will cancel in letter B?
N. So yeah, that's minus that, n minus 1 and n minus 2.
So everything back behind there?
Yeah.
So what's left, Miss Natalie?
Plus 1.
N plus 1. Huh. So can we do factorials with just variables in? Yes, we can. Okay. All right. Good. Flip it. Now, hopefully, guys, you can generate a sequence with factorials. I don't think we need to generate a sequence with factorials because we have to hit summation notation. Also called sigma notation. For anybody know what sigma is?
Is it like
Yeah. From what alphabet?
Greek?
Yeah, it's from the Greek alphabet. Okay. Okay. So before we talk about sigma notation, we're going to talk about what a series is. Because this unit, guys, is called sequences and series. A series is a list of numbers separated by addition. So the only big difference between a sequence and a series is a sequence is separated by commas, series separated by addition. Okay? A series can be written in summation notation. Okay? So let's take the sequence that we had yesterday, but let's write it with pluses in between. The one we started in our notes yesterday was 3. Oh, was it 3, 6, 9, 12? Yeah. Plus 6, plus 9, plus 12, plus 15. It was finite from yesterday, is that correct? It was 3, 6, 9, 12, 15. All right, this is a series. Big deal, you have addition in between. Okay? A series can be written in summation notation. So here's what summation notation looks like. That's sigma. Okay? Right here goes the explicit rule. Now, instead of n equals, sometimes they use I equals. And right here, starting term number. Okay? Up here, ending term number. Okay? And what this stands for, when you see this, that means sum up these terms. They want you to sum them. Okay? So when you see this, that means sum up the terms. Okay? So, can we take this series, and do you guys think we could write it in sigma notation? Now, I really don't care if you use I equals or n equals, it doesn't matter. Do you guys want to stick with n for term number right now? Yeah. Okay. All right. Sierra, looking at this sequence, what's the first term number? This is term number
3.
That's the answer in the position.
N equals
1?
Yeah.
Good. And then Kayla, what's this last term number? 5. Okay, now anybody confused about that? Okay, and then we need the rule. So remember the rule from yesterday. What do you do to 1 to get 3? What do you do to 2 to get 6? What do you do to 3 to get 9? Somebody got the rule for us? What do we do with the n number? Brianna? So 3n? Yes. And don't get confused if you see the notation 3i. Sometimes they use i's, sometimes they use a's, sometimes they use k's. They use all kinds of them. Now, could we guys actually evaluate that then? Okay? If it just says write it in sigma notation, you're done. If it says evaluate, then you actually have to sum these up while they're sitting there. So can you guys sum those up?
6.
What'd you guys get for a sum? 45. Anybody concur?
Yeah.
Yes? Okay. If they just say write in sigma notation, you're done right there. If they say evaluate, then you have to go further.
So-
I'm just adding them up
Oh,
because they're sitting there, so you just add them up.
It's gonna,
Yes.
what's the point of the sigma notation?
Um,
Do
you know, let me think about that. I'm not sure exactly where they use it. I think they use it in calculus. Okay. It's a way to write the sum of a very large number,
Okay.
is one way to do it. Okay? All right, let's do this one. Sigma I equals 1 to 6 I squared plus 1. Okay? So now this one says evaluate. Okay? It wants me to generate how many terms, Nat? Huh? 6. All right, so guys, put 6 slots. 1, 2, 3, 4, 5. I gotta write one below. 6. Lexi, because it's a series, what goes in between each slot? If it was a sequence, we would put commas. If it's a series, we put addition. Good? Okay. Lovely Jasmine. The first, well, let me do the first term and then you do the second term, is when I equals 1. So I'm going to write 1 squared plus 1. Lovely Jasmine, when I equals 2, what do I write next? 2 what? 2 squared plus that a girl. Good. Rachel, keep going. Next term.
3 squared plus 1.
Max, next.
4 squared plus 1.
Mason, next. Good. And Maya, next.
6 squared plus 5.
Okay, sounds good. All right, let's put our sigma. Do you guys want n equals or I equals? Doesn't matter. To anybody? So n equals. All right, Max, what's the first term number?
1.
1. Max, what's the last term number?
7.
Yeah. Okay. Anybody have the rule then? What do you do to 1 to get 1 cubed? What do you do to 2 to get 2 cubed? What do you do to 3 to get 3 cubed? What do you do to n to get?
N cubed.
There you go. Thanks for giving me the rule. So it's just n cubed. Okay, that was easy, right? Next one, n equals. First term is when n is 1. Then n is 2. Then n is 3. Then n is 4. This one, the rule isn't going to be so easy. Okay? All right, Mason, n equals 1 to how many if we have dot, dot, dot? Yes. So everybody know your little infinite symbol? Now, when you have a fraction, all these tops, do you notice, are the number 1. Write a rule for the top, and then write a rule for the bottom. So 1 is like 1 over 1, is it not, guys? So what do you do to 1 to get 1? What do you do to 2 to get 3? What do you do to 3 to get 9? What do you do to 4 to get 27? Okay. Now, guys, if you couldn't get this, you'd go to your graphics. In list 1, you'd put 1, 2, 3, 4. In list 2, you'd put 1, 3, 9, 27. And it would come out to be the exponential model. This is the exponential model. So would your graphics calculator give you this bottom rule? Yes, it would. Okay, so you can use your graphics to get the bottom rule. Okay, all right, good. Here's what I want to